They call them the Fortunate Islands, and in many ways they are. The Isles of Scilly, 100 toy-like islands set in the Atlantic, 28 miles southwest of Land's End, seem to inspire those get-away-from-it-all feelings which are the dream of many a mainlander. The climate is mild, the sunshine strong, the beaches sandy. People have savoured these island delights for at least 4,000 years. But nowadays, the 2,000-strong population inhabit just 5 and leave the rest to the birds. Fortunate they certainly are, but there are drawbacks too. Distance may lend enchantment, but it also puts a high price on every mainland commodity which has to be shipped across the water to the Scillies. Food, drink, fuel, they all come courtesy of the RMS Scillonian III, and that's a service that has to be paid for. Most of the population live on St. Mary's, by far the largest of the islands, and the nerve centre of the whole Scillonian lifestyle. The local council offices are here, so are banks, shops and hotels, and also the power station run by the Southwestern Electricity Board. For years, the station supplied only St. Mary's, using 6 generators with a total capacity of 3.5 megawatts of power. 2 of those generators operate at 11,000 volts. The other 4 at low voltage, which is then stepped up to 11,000 at the switchboard. At the switchboard too, the power is distributed to feeder circuits which carry the electricity to people in the town and country areas, and also to the larger undertakings such as the hospital. Along with all the other mainland commodities, the Scillonian brings the fuel for the power station. The generators run on diesel oil, and the stocks on St. Mary's are regularly topped up to make sure they don't run out. A SWEB fuel lorry makes regular runs from St. Mary's Quay, where the diesel is unloaded from the Scillonian into store, up the hill to the power station. At the station, it's piped into the fuel tanks, ready to be fed to the generators. On the other inhabited islands, Briar, St. Agnes, St. Martin's and Tresco, apart from a small generating station on Tresco, the luxury of mains electricity had for years been nothing more than a pipe dream. Instead, the householders had to provide their own electricity supply. Here on St. Martin's Quay, there are no handling facilities at all, and while this was fine for the able-bodied, the elderly and the women just couldn't maneuver the drums in the same way. But it wasn't only the inconvenience and messiness of carting heavy loads of fuel around by tractor. It was also the cost of the whole operation, which could amount to 5 times as much as St. Mary's mains. Also, 2/3 of the private generators were shared with the house next door and provided only limited facilities for short periods of the day. On average, the off-islanders were running their generators for just 6 hours a day, and a noisy 6 hours they were. The systems linked to the generators were also quite primitive, and whenever anything broke down, it often presented a major maintenance problem. No wonder they kept the electrical installations in their houses as simple as possible.
Our approach to supplies on the 4 off-islands of the group.
So when, in 1984, SWEB approved a carefully conceived £3 million scheme to put mains electricity from the power station onto the 4 off-islands, there was hardly a dissenting voice to be heard. The plan was to construct an 11,000-volt distribution system linked to St. Mary's by submarine cable, while on St. Mary's itself, the existing network was to be strengthened. A mobile generator was also to be kept on standby. The manufacture of the all-important 11,000-volt submarine cable to run between the islands was put in the hands of AEI Cables of Gravesend. They rank among the world's most experienced cable makers, and their factory, which has been at Gravesend since the beginning of the century, is equipped with some of the most advanced cable-making machinery available today. It was decided that the most effective submarine cable design for the Scillies would have a stranded copper conductor with paper insulation, lead sheath, and double wire armor. The double armoring was advisable because of the particularly formidable installation conditions, a rocky seabed combined with fast tidal undercurrents. The copper conductors start life as lengths of wire drawn down to the required size, in this case 1.85 millimeters. These are then stranded together to form the conductor, a giant weaving process, criss-crossing the wires around a single central strand to build up to 19 altogether. All 3 conductors for the cable are made in this way and then coiled onto a drum. Next, the conductors are insulated using a paper lapping process. A semi-conducting shield of 2 carbon papers is first applied immediately over the copper conductors. Machine heads then wind layers of wood pulp paper onto each conductor to make it precisely 2.8 millimeters thick. Finally, a numbered tape is added for core identification, followed by a perforated metal foil laminate to form the core screen. The 3 separate cable cores, that is the conductors plus their insulation, are wound onto drums ready for the next stage, when they're married together and begin to take the shape of the finished cable. This is the laying up process, when jute is pressed in to fill the spaces between cores and to turn them into the familiar circular shape. Finally now, the cores are bound together with a cotton fabric tape. Woven into this is copper wire to form an electrical connection between the cable's lead sheath and individual core screens. Next, the cable is transferred to a pan ready for the impregnation process. During this operation, moisture is removed from the insulating paper by a vacuum process and replaced under pressure by a high-quality electrical insulating oil. The sealed pan is heated, the moisture extracted, and hot oil poured over the cores, filling every space it finds and ensuring there could be no future breakdown of the cable. The cable is left in the pan for several days for the oil to soak in, then lifted out and any surplus oil allowed to run off. The oil, which has impregnated the core paper, makes a perfect insulation. The cable is now ready for its lead sheath. Again, this provides protection, especially against moisture. The sheath is applied by running the cable into a die, where molten lead is extruded onto the cable to make a continuous uniform layer. The lead sheath has to be 2 millimeters thick, and a constant check is made with an ultrasonic gauge. The output of the extruder can be adjusted as required. As so often during the various production stages, the cable, now lead-covered, is wound onto a drum for the next application. This time it is passed through a bitumen bath to provide a key for the next layer, an extruded PVC bedding. Hot PVC takes some time to harden, so the cable is passed through a long trough of water to cool it and keep it in shape. As at all stages of the manufacture, careful measurements of the cable are taken to ensure that the jacket complies with the specified thickness requirements. Also, a high-voltage spark test confirms there are no imperfections in the extruded layer. Now comes one of the most skilled operations of the whole process, the jointing together of the cable sections into one continuous length of 16.5 kilometers. First of all, the cable ends are stripped back to the copper conductors, which are then brazed together. Next, The black carbon papers are reinstated, ensuring continuity across the jointed section. Now, the impregnated paper is added. This is done in steps, each overlapping the previous one to avoid any weakness. The reinstatement of the insulation is completed by the application of metallized paper screening tape. As before, the jute filler is laid between the cable cores to give the correct shape and to fill the gaps. The last stage of fabric addition is the woven cotton which binds the whole cable mass together. Jointing is a job which can't be hurried, with each joint taking several hours to complete. A lead sleeve had been placed on the cable before the joint was started. Now this is pulled over the newly made joint to cover it completely. Then, in order to produce a tight fit and to ensure there is no increase in diameter, the lead sleeve is swaged down onto the cable. Now comes a vital process, burning lead into the sleeve to seal it against any possibility of moisture seeping into the cable. This is very skilled and painstaking work. Yet another seal is applied to the lead, and then it's time to restore the PVC sheath. To ensure a satisfactory bond and to act as further moisture barrier, a layer of hot melt adhesive tape is applied on and beyond the reinstated lead sleeve. The PVC sheath is in the form of a heat shrink tube, which had been run onto the cable before the joint was started. When heat is applied to it, the tube shrinks down and beds itself onto the cable. Finally, black tape is bound around the cable to smooth out any bumps in the joint, which is now as strong as the rest of the cable. At last, the cable is ready for the final stage in this careful manufacturing process. This is when the wire armor is fixed around the cable to give it a lifetime of protection against rocks and tides. First, a bedding of jute is applied to provide a firm foundation for the armor. The galvanized steel is 6 millimeters in diameter, and there are 26 wires in this first layer. As they're wound on, a bitumen compound seals them in and fills the space. Hessian tape makes the bed for the second layer of armoring. The second layer consists of 32 wires. It's vital to lay these in the same direction as the first carriage. Otherwise, it won't be possible to coil the cable. Further applications of bitumen and jute strings are made until the cable has been finished in line with the specification. To prevent the cable adhering to itself when coiled down, it was coated with whitewash before being fed into a huge storage pit. Here it waited for Balfour Kilpatrick's cable-laying ship, the Guardians, a 600-tonner which was being fitted out upriver at Piper's Wharf, Greenwich. The modifications to the ship included making 2 coiling tanks for the cable, fitting rollers to run the cable out of the tanks, and a stern skid for paying it out. Winches for shore-end mooring wires were also installed, as well as a bow skid for launching the anchors. When the Guardians arrived at AEI's works at Gravesend, the cable was taken along a gantry on rollers to be loaded into the ship. This particular operation took several days because the gang transferring the cable from the pit into the ship had to work very precisely. Correct coiling at this stage is the secret of successful cable laying later. First, they loaded the forward tank, Then, when that was full, the rest of the cable was coiled down into the aft tank in a way that would ensure a smooth flow during the entire laying process. Meanwhile, back on the Scillies, the electricity board team was getting together all the equipment and materials needed to install the distribution system on the off-islands. It was quite an exercise in planning and execution, as everything first had to be brought from the mainland of Cornwall to St. Mary's and then taken across to the outer islands by small boat. Cement mixer, cement, mechanical digger, transformers, cables, switchgear, meter boxes. Even Land Rovers had to be loaded aboard and shipped out to each of the islands in turn. After reinforcement work on St. Mary's, Swebb got down to the business of putting in the distribution system on the off-islands themselves. Mostly the cables went underground, thanks to generous help from the Countryside Commission and the Duchy of Cornwall. The Nature Conservancy Council advised on cable routes to help safeguard the unique environment. After laying 200 meters of cable, the trenches were backfilled so there would be no pitfalls for unwary passers-by. Altogether, 220 people on the 4 islands opted for a supply, each paying £1,000 towards the total cost of around £3 million. Just over £1 million of this came as a handsome contribution from the European Regional Development Fund. The Swebb crews worked around the clock 7 days a week to put the system in, and their dedication was a constant talking point with the islanders. Never before had the off-islands been excavated in this way, with 18-inch trenches gouging through the land. The Institute of Cornish Studies at Camborne put a small team of archaeologists on the Scillies to follow behind the digger and carefully rake over the stones to learn more of the history of these ancient islands. And they turned up large numbers of artifacts, including flint tools on Tresco, prehistoric pottery on St. Agnes, and medieval pots on St. Martin's. When the archaeologists' work was done, the cable was laid, yellow marker tapes placed above to warn future excavators of the high voltage electricity below, and the trench backfilled. Standard practice, of course, for Swebb anywhere in their southwestern area. Only one short section of the scheme remained overhead, on part of Tresco where previously an overhead line system supplied low voltage power from a private generator. The Swebb took care to place their poles away from the skyline as much as possible to preserve the unique landscape of this beautiful subtropical island. At various points around the islands, plinths were made for the high voltage switches and transformers needed to convert the power to the correct voltage for supplying the customers. These pieces of equipment are heavy and need a strong base to prevent subsidence. Some of them are also different from those normally used on the mainland, with special low-voltage cabinets attached so that the distribution cables and service cables to the houses could be run straight from them. Each property had to be fitted with its own meter box. These were placed on an outside wall so that when the meter reader calls, he can take his reading even if the occupants are away from home. Besides the archaeologists, other people also took advantage of Swebb's trench work. There's been a telephone system on the islands for many years, with the lines running overhead. But now, where they could, British Telecom put their lines to bed with the Swebb cables underground. One very special person who paid a surprise visit during the installation work was Prince Charles. As Duke of Cornwall, he owns 4,000 acres and 200 tenancies on the Scillies, and like a good landlord, he visits the islands very regularly. To the locals, he's a familiar figure, but for the visitors, the occasion was tailor-made for present giving and snapshots for the family album. But the main purpose of the Prince's visit was to meet the SWEB staff in Cornwall who were busy installing the main scheme. He was particularly impressed with their versatility and the range of tasks they were able to carry out, very important this, in a team effort far from home. The Prince also inspected a sample of the high-voltage submarine cable, which was to be laid between the islands by Balfour Kilpatrick, experts in this kind of work. And while the day-to-day business of living on the Scillies went on, BK's cable ship Guardians arrived on station to lay the inter-island connection. The method to be used is a well-tried one. The Guardians backed into a set of moorings carefully set down in the right place. A pulling wire was run ashore, taken around a pulley block and back to the ship's winch. The other end was then attached to the cable to haul it ashore in a carefully controlled fashion. And so the first section of the cable was slowly fed over the stern skid into the water. Fixed to the leading end was a barrel with floats secured behind it to give buoyancy to the cable and to ensure it kept clear of the seabed as it came ashore. Enough cable was paid out from the hold to reach the link point with the land cables. All the time the cable was moving ashore, the tension was kept on until the correct length was run out with divers ready to remove the floats and let the cable sink to the seabed. Carefully, it was taken up the beach, supported by rollers for ease of handling and to make any small adjustments needed to bring it exactly on course. As soon as it was ashore, the divers cut away the floats, an operation suitable for local men used to the conditions. With the cable down, it was then a question of waiting for time and tide to carry out the actual lay. The signal went up at the masthead, and the lay was underway. Slowly, the Guardian sailed out of the mooring pattern at 2 to 3 knots, disgorging the submarine cable from the hold as she went. As the cable came out of the tank, it passed through all the controls to maintain the correct tension to prevent loops of slack cable forming on the seabed. There were 6 brakes mounted by the stern skid, operated by a brake crew, and the angle of the cable going down into the water was kept between 30 and 45 degrees to help give the right tension. On the bridge, the helmsman steered his course from a visual display unit fed with information from navigation beacons set up at various points on the islands. This ensured that the cable was laid along a route determined after carrying out a seabed survey some months before, and the laid positions plotted to within 1 meter. The local expertise of a Scillies pilot also helped to keep the Guardians on course, as the helmsman made his way through shallow waters to the other end of the lay. Once again, the Guardian sailed into a pattern of moorings, ready to pull ashore a length of cable to complete the lay. The rest of the cable was also still on board, so the distance from ship to shore was carefully measured, and the exact amount of cable needed coiled back into an empty hold to be cut. Now, the test of accuracy. Get this wrong, and BK would be faced with the unkindest cut of all, a cable that wouldn't reach its termination point. But the cut was good, and the end of the cable was sealed to keep out the water when it was taken ashore. Now, the cable was made ready for its short journey to the beach. First, the armor wires were laid back, and then formed into a pulling eye for fixing the winch wire to haul the cable ashore. The end of the cable was taken ashore on floats in exactly the same way as at the other end of the lay. Again, the cable was hauled in by the winch on the Guardians, with the tow wire running around a block on shore and back on board. This time, of course, the ship had her bow to the shore, and the cable was paid out over the side. This was the procedure BK followed for laying all 5 lengths of the cable between the islands. The only exception was that between Tresco and Briar, where the crossing was so short that the Guardians moored midway between the 2 islands and the cable was pulled ashore on floats each way. The cable was laid in springtime because it was thought the weather would be favorable then. For much of the time it was, allowing the crew to press on at speed in order to finish the work before the summer visitors arrived. It was work that many of them had done before, and this showed up in the professional way in which the job was done. As soon as the leading end of the cable was in position on shore, the last loop was lifted clear of the gear on the ship and placed in the water. This was slow and laborious work, as the cable had to be lowered manually and very carefully by ropes down to the seabed. Close radio contact was maintained between ship and shore to make sure there was tension on the cable the whole time. This tension was held at the shore end until the last section was placed on the seabed. When it was down, the divers removed the remaining float bags and settled the cable in position. The divers also checked 80 meters out from low water to ensure there were no rocks in the way. Had there been, they would have moved the cable slightly to one side with airbags. As the cable was buried in the beach, a plastic marker tape was placed above it to indicate its presence. On the shoreline, and 80 meters seawards underwater, it was protected by 50-kilogram concrete bags. This was to reduce action by seawater and give protection from boats and fishing trawls. While on shore, a warning notice told ships to keep a sharp lookout. And now, the moment of truth. The system was complete, it had all been tested, and it was time to switch it on. At Bar Point, on the northern end of St. Mary's, the 2 switches controlling the feed to St. Martin's and to Tresco were closed, and the circuits went live. On the islands themselves, the substations were activated, and the power began to flow. This complex inter-island connection had been completely finished in a mere 8 months, a triumph for Swebb and a miracle for the islanders.
I always look forward to any opportunity to come to the Scilly Isles.
Once again, Prince Charles came back to the Scillies, this time to commission the new system. The formal ceremony was held on St. Martin's, in the garden of the first property to get mains power. Many of those attending had helped in the project, either working on it or providing grant aid towards the cost. The Prince was clearly delighted with the result.
Walk over there and hopefully pull the handle and ensure that from now on the off-islands are kept ticking over gently with delightful, clean and silent power.
Yeah. Pull that down.
For this householder on St. Agnes, the miracle of electricity was soon turned to a practical use. Like many in the Scillies, she relies on tourism for a large part of her income, and it's much easier to cater for the needs of the visitors when the kitchen's equipped with modern electric appliances, especially with a tourist season that lasts right through from March to October. But it's not just the quality of life in the kitchen which has been improved by mains electricity. It has also provided power to the elbow of the commercial life of the off-islands. Model boat buildings, just one of a number of small crafts which have benefited from the arrival of a constant and reliable power supply. Full-size boat building, flower growing, the hotel business, they're all running much more efficiently thanks to electricity. So now, almost as if they've been doing it since the beginning of time, the islanders are switching their switches and plugging in their plugs to make the most of the new power around the Scillies.